Okay, so let's begin with some warm-up problems. There's 100 dots in this graph you see on the screen. What proportion of these dots are at least 0.13? So the answer to the question, we look on the horizontal axis until we get to 0.13. So here's 0.1, 0.12, 0.13 is right here. And we want to be at least, so that means equal to 0.13 or greater. So that's these 9 dots right here. So there's 4, 4, 1, 9 dots overall out of 100. The proportion is 0.09. So let's modify this a little bit. Here's 100 dots. Now the question is, what's the proportion that is at most 0.13, negative 0.13, or at least positive 0.13? Well, negative 0.13 is right here. So there's this 1, 2, 3, 4, 5, 6 dots that are negative 0.13 or less. And on the right side, we counted 9 dots that are 0.13 or more. So combine those. That's 6 plus 9 or 15 dots that are less than at most negative 0.13 or positive, or at least positive 0.13. That comes out to be 15 of 100 or 0.15. Oops. What proportion of the histogram is less than negative 0.1? So again, you look to see where negative 0.1 is, and it's right there. Less than negative 0.1 means we want all the bars that are left of it. So we take this bar, which looks to be at 0.05. This bar, I'll estimate to be 0.045. And then this one around 0.01. As you find the heights by going to the left side of the scale there. Add them up. 0.01 plus 0.045 plus 0.05. That comes out to be a proportion that's about 0.105. All right. Earlier in previous lessons, we explored whether women were discriminated against and whether a simple trick could make students a little thriftier. However, in these studies, we overlooked some possibilities. First, what if men had been discriminated against? Or what if the money trick makes students spend more? Now, we didn't consider these possibilities, and this may have seemed natural since the data pointed in the directions which we framed the questions. However, there's 2 problems when you only look at one side. So if we ignore possibilities that disagree with our data or conflict with our worldview. First, framing an alternative simply to match the direction of the data will generally make a type 1 error more common. So it'll inflate the type 1 error rate. Also, if we only use alternative hypotheses that agree with our worldview, then we're going to be subjecting ourselves to confirmation bias. And this means that we're looking for data that supports our ideas. Not particularly scientific, and we can do better. So, previously, just for the sake of simplicity, we only considered one-sided hypothesis tests, since they explored one direction of the possibilities. Such hypotheses are appropriate when we are exclusively interested in a single direction. Usually, however, we would like to consider all the possibilities. So to do this, we would use a two-sided hypothesis test.